What's up, everyone? This is Dr. Jax. Today we're going to look at concave and convex mirrors and how we can use light ray diagrams to figure out where the focal point is. In order to do this, we're going to have a laser that is sliding up and down as well as spray mist to show the path of the light rays. What you're going to see is the laser starts exactly perpendicular to the center of the curve, and you'll see that the light bounces straight back perpendicular to the surface. But as the light moves up and down, you'll see how that angle of reflection changes. Based on where the light rays cross, we can calculate and predict where the focal point will be located. So first we're going to watch this in full speed, and you'll see how the light rays bounce back. And then what I'll do is pause at a few different places so you can see how the light rays converge into one spot. Where the light rays converge, that's where the focal point exists. This is called a converging mirror, and so the light rays will actually bounce back and overlap. Let's watch. Okay, and now what I'll do is I'll pause it at a few locations and show you the ray diagram. So first, when the light is above the center of curvature, we'll have the light ray go into the mirror like this and bounce back like that. If it is focused directly at the center of curvature, you see how it bounces straight back. So we'll leave one line going straight back upon itself, bouncing right back upon itself from the laser. And then when we jump to a place below the center of curvature, we'll have the light ray entering, approaching the mirror like this, and then bouncing back this. And right here where the light rays converge, that is the focal point. All right, as opposed to the concave mirror, this is a convex mirror. A convex mirror is considered to be a diverging mirror, which means that as the light rays strike the surface, they will bounce away from each other and never actually come together and form a single point in front of the lens. So in order to find the focal point, what we'll do is we'll trace them behind the mirror and see where they converge. This type of mirror forms a virtual image. And based on the location of where the light rays converge, we use the opposite side of the mirror to calculate and predict where the focal point will be. So again, we'll look at this in full speed once, and then I'll draw the ray diagram so you could see how they actually converge. Okay, and so what we'll do again is we'll start with one line that goes directly into the center of the curve. Okay, and I'm going to place this line so it extends back behind the mirror so you could see what we're going to end up doing in a second. And then we'll jump to a place where it's above the starting point. And so we'll draw the first ray going into the mirror like this, and the reflected ray now bounces back like this, okay? And you can see how if we trace it backwards, it overlaps our first line over here. This is where the focal point is going to be located. Now, if we go below the mirror, what we'll do is the same thing. So we'll draw our ray going into the mirror like this. And then our reflected ray will bounce out like this. And you can see that they all overlap at one point behind the mirror. So this would be the focal point. And if you measure from here to the center of the mirror, that would be considered the focal length. And that is how we look at concave and convex mirrors.